Well, good afternoon, good morning, everybody. Um, Glad to see you join us for the webinar here. We'll give everybody just a couple minutes to filter in and then we'll get started. Looks like we've got everybody in, so we can go ahead and get started. My name is Jeff Ledbetter. I'm a client success manager here at Datamark Technologies, and we're excited today to present on the data stewardship NENA information document, Mastering GIS Data Stewardship, NENA Standards in Action. I was just getting ready for the webinar here and talking with Stephanie, our marketing director, and just saying to her, like, there is so much content in this good document that we could probably have a year's worth of webinars about it. I promise that probably won't be the case. We won't give you a year's worth of that. The good news about that is that means I don't have to try to cram everything in all at once. So you'll see today as I advance to our agenda. In fact, let me turn my video off so I can preserve my bandwidth. Advance to the agenda here. We're going to talk about the NENA information document for GIS data stewardship for Next-Gen 911. The last time you saw me on this webinar series, we were talking about the same. So we'll have a little bit of review here right up front, but get on to some new content about that. It's really focused on the stewardship of GIS data used for the ECRF, the emergency call routing function, and the LVF, the location validation function, and general requirements common to all GIS data layers. You'll remember that this document was published in 2023. It is NENA INF 028.2. It covers such topics as the data sets needed and how they're used. So the GIS data model standard tells us what data sets are required. The NENA standard for the Civic Location Data Exchange Format, or CLDXF, tells the types of data how data is populated in terms of civic address location information. But this information document is really there to give you some information about how to apply those two standards to your GIS data so that you meet those standards, as well as some operational considerations in terms of public safety entering point, PSAP or ECC systems, as well as other business systems. So it does a good job of helping the GIS data provider, who may or may not be, directly attached to a PSAP or an ECC, but needs to balance and comprehend the requirements for both NG911 systems and uses, as well as other business systems and uses such as transportation, other financial types of systems that might use the same data. And there are specific recommendations for the creation and maintenance of service boundary layers and road center lines. There's not a lot. There's reference to and talk of site structure address point data. However, there is not a lot of specific recommendations about the creation of that site structure address point data yet, right? That is likely to come in future versions. Its audience is the GIS and PSAP staff involved in NG 911, and it takes an in-state perspective as opposed to a transitional perspective. So that's an important distinction to understand about this document versus the GIS data transition document that kind of overlaps a little bit in terms of what it talks about. But what makes this one different from that is that when it does overlap, this one is speaking of that in-state of being for your GIS data, so that you're not thinking about and worrying about things like what is the transition where you're doing a dual maintenance of IMSAG, ALI, and GIS, but really what does that in-state maintenance look like and needs and concerns look like for when you're fully on board into a next-gen core service environment that has a fully functional ECRF, again, emergency call routing function, and LVF, location validation function. I'm sure that the SSAP will be covered in future versions. However, there is an existing information document that talks about the creation of site structure address points already. I don't think there would be too many people that would disagree with the statement that would acknowledge that that document is useful, valid, but perhaps a bit long in the tooth, and some recommendations probably have come along or need to come along since that document's been created. So I think there is and will be an opportunity in the future for that GIS data stewardship working group to take on the important points about site structure address points creation and maintenance as well. But all that to say that that's not in there now. And I forgot to mention, as always on our webinars here at Datamark Technology, we invite everybody to chat, interact in the chat, to utilize the question and answer functionality of Zoom. If you have a pressing question, please put it in there. Rob asks about that last comment I made. When in the future do you expect discussion of that to be covered? NENA, the document development process at NENA is a complicated one, and necessarily so, I think. To my knowledge, there isn't currently an open opportunity for the GIS data stewardship document working group to create those, but it will be coming. I've heard that at both the joint committee meetings as well as the standards and best practices conference, and I anticipate that we'll be hearing in the next, I don't know, 3-4 months about the opening of that working group to start looking at, among other things, site structure address points. Okay. So today, what are we going to talk about today? As I mentioned, this document is just stacked full of great topics and recommendations, and so we're just going to get through a couple of them here. We'll be in section 5 about civic location layers, about road center lines primarily. And we'll get into some of the very specific documents. You'll see down there 5.4.1 through 5.4.6. It actually goes all the way through 5.4.13. And I had initially hoped when developing this content that we could get through all of those 5.4.1 through 13s, but there's so much to talk about in the first 6 or those 13, I should say, that I decided to kind of cut it in half. And in our next series, we'll talk about the rest of them plus some more. So we'll have some information about that at the end of this webinar. So let's get into it here. In section 5, interestingly, and I'd read this many times before, but for some reason when I read it this time, I thought to myself, well, you know what? That was really smart. This is a good place for this information here. What is the purpose of the road center line as it relates to NGCS, as it relates to NG 911? Certainly that would be discussed in the data model, and probably some other places as well. But I was really glad to see that they included this specific information here about the purpose of that. And that, I'll just go ahead and read this to you, and I'll make this statement as I did in the last webinar about not only this document, some of our other standards as well, webinars that we've done. I'm going to wind up reading to you some of the exact text of the document because it's so well put together and so succinct in its composition that it's hard to kind of bulletize or boil it down anymore or rephrase it in any useful way. So I'm going to wind up reading a bit to you here and then talking about that. And hopefully that is educational for you. Maybe it spurs some questions. And as I said, please feel free to put those questions in the chat or the Q&A box and we'll address them. So what is the purpose of the road centerline layer in NG 911? It says this layer is used by the LVF to validate a civic address that is also used by the ECRF to perform a geographic query for a civic location against service boundaries to determine to which PSAP an emergency request is routed and which emergency responders are applicable. An emergency call is routed within the I3 core elements based upon its geographic location, provided either as a civic address or a geodetic location, as defined in the NENA I3 standard for NG 911. So interestingly, right, this is the biggest use of the road center line, and this will actually detail this even more here in the next slide or two, for the road center line is to allow for the geocoding of addresses, civic addresses, for validation in the LVF and then also in the ECRF, but it's also going to be utilized in places like the MCS, the MSAG conversion service, the GCS, the geocoder service, the MDS, the mapping data service, and I forget if that's the right, is it data or database? I forget what the current version of that is. But that road centerline GIS data is going to be used in multiple places, but the most primary one is there in the LVF to validate and the ECRF to perform a geographic query. Yeah, LVF, ECRF, again, location validation function, emergency call routing function. Take a look at that NENA I3 standard if you don't fully understand the operation of those elements, functional elements. Oops. So what are the civic location requirements? Site structure address points are essential for those areas where the RCL layer is incapable of providing location validation accurately. In fact, I would even state that the site structure address point, because it is by its nature more precise than a road centerline layer, that the relationship is kind of flipped there. If we don't have a specific site structure address point for a civic address, it's going to fall back to the road ranges and the road names of the road centerline layer to go and find where that location is by geocoding or interpolating against that layer what the location is, right? Jurisdictions should plan on developing a complete site structure address point layer if they do not already have one. So I started out by saying this doesn't talk about much about site structure address point layers, but the first thing out of the box is you should be creating a site structure address point layer. It is a required layer in the GIS data model, and there is a relationship, a key relationship, and it's important that whatever sort of data validation tools you may be using validates against that relationship and points out places where that relationship is not working properly, right? So after, here in the second bullet point, after the RCL and SSAP layer synchronization with IMSAG and ALI databases, right? The RCL and SSAP layers should allow for the verification of all the addresses that were validated by the IMSAG. It's bolded here. Maybe I should have underlined and highlighted it as well, because it cannot be overemphasized that this really is why the RCL and SSAP layers exist, right? It is to replace the civic address locations that were located, that are found in the IMSAG and the ALI, right? The legacy 911 databases, the master street address guide, and the automatic location information databases. And if your GIS data cannot validate the locations and find the locations that your IMSAG and ALI have in them, then it is not complete enough. It is not accurate enough to be used in a next-gen 911 environment. The third bullet point here, the appropriate attributes need to be fully spelled out according to the requirements of the CLDXF that I mentioned earlier, before uploading to the NGCS databases. Now, this is an interesting one that we get asked about a lot, right? We're working with clients to prepare their data for it. You know, do I really have to have everything spelled out? Do I have to have it in the right case? And the answer to that question is really only if you want it to be standard compliant, right? And of course, we want it to be standard compliant because that's why we're here. It is the interoperability that is provided by this state of being, right? Imagine, so let's talk about why does that provide interoperability? If you use 2 digits to abbreviate avenue, and I use 3, and Sally down the road uses a fully spelled out version of the word avenue in lowercase, and you know, Jim further down the road uses fully spelled out, but it's in title case. Then how do we get interoperability between these 4 different formats of the data? We really don't without a lot of particular gymnastics, right? And those gymnastics can be done in different ways, and that is kind of opposed to the purpose of a standard. And so if we all go through and reformat our GIS data to only use the word avenue in title case as is specified in the standards, then we have interoperability. Now, that's easier said than done, perhaps, because these GIS data sets all have context and other systems that consume it. And so what I like about this document, the GIS data stewardship document, is that it really acknowledges that, and it acknowledges the fact that the world is not a vacuum, and that this data is probably not existing only for use in these next-gen core service systems and next-gen 911. The fourth bullet point, more information regarding that. I said earlier, there is an existing NENA information document out there. This is it, the NENA information document for development of site structure address points for GIS data for 911. A very useful document, a good one with lots of good recommendations and good structural advice on site structure address points, and one that I hope is made even better in the future. So section 5.3, what are some considerations when developing civic location layers? Same data is used for call routing and location validation, can and likely should also be used for other purposes to mitigate conflicts between the 911 system and the PSAP's ancillary systems, such as computer-aided dispatch, right? Computer-aided dispatch uses GIS data depending on your vendor, depending on your version. Can use GIS data to populate all the quick search tables that they contain, populate, interpolate things like intersections, intersection names, make all the typing and searching that happens in a CAD scenario faster. And certainly there is a map display that comes with most CAD systems, not all, but most. You would be benefited greatly by using the same GIS data for that as you would your NGCS, your Next Gen Core Services, for NG 911 call routing. I think that is a kind of obvious connection there, but there is no visual element, right, to Next Gen 911. It is a machine-to-machine interface, a series of machine-to-machine interfaces that make determinations on what PSAP to route a call to, among other things, based on many data sets, a good number of which are spatial. So when does that visual element come to play? Well, it doesn't come to play in NextGen 911 specifically, right? Call routing. It comes to play in these other systems. Computer-aided dispatch is where you start to visualize that same data. So if the machine-to-machine interface is looking at a different data set, it may actually find a different location for the same civic address than the other data set that's being displayed in your CAD, your mapped alley, or other GIS systems. So I would make the argument, and this document does as well, that they should not be different data sets, but they should be the same so that there is, again, interoperability and uniformity in representation of a given civic address location, even a given geodetic location as well. Mapped alley displays are the maps that give some visual reference as well that can correspond with or connected to your call handling equipment. And so again, if a call comes into a specific location routed to that call handling equipment, the visual elements of that should reflect the same data that is used in that machine-to-machine interface that determines the routing. And transportation planning data is another place where road center lines are pretty critical. And there comes a little bit of a conflict. I don't know if it's really a conflict, but two different ways to kind of see those. An LRS, or a linear referencing system, if you're not familiar with that, is used in transportation systems, is used in construction. If you've ever had the joy to sort of look over civil engineering plans for a road or a highway system, it kind of has this big line down the middle of it. It is that linear reference that really doesn't use at all road names and address ranges. Instead, it uses a station 100. You got it, James. It uses that starting point, a point of beginning, and then it measures events. So if you're an ArcMap dinosaur like me and you've heard of events tables, that's using a linear reference system. It uses a similar geometry, and then measures the distance to the event, and then an offset distance off of that location to note where signs should be placed rather, or where striping should be done a certain way, or where the call boxes go, or this information or that information. It could even be used to locate the site structure address point off of a distance and bearing off of a linear referencing system. And so 911 systems go out and find civic addresses generally by using the road name and address range. LRS systems in the transportation world use a distance and bearing to do the same. For a long time, I've sort of harbored in my brain a desire to kind of crack the code to figure out where those two things come together. And the holy grail of that idea is that you might be able to have one set of geometry that could function for both systems. I've been at this game for a number of years and I haven't cracked that code, and I've talked with a lot of really smart people out in the world that are also have thought about cracking that code, and it's not been necessarily done yet. But I wouldn't be surprised at some point in the future if there isn't a way to use the same geometry for both. And so that was important enough for this document to mention the possibility. And so I think it's a good thought to mention here as well. And if anybody ever wants to go have like a little nerd out session and think about LRS connecting to address ranges, I mean, man, I'd love to chat with you about that. In that same section as well, it adds that when validating call routing based on road centerline, in some cases, it may be necessary to not modify address ranges, offset distance, or geometry so that offset address locations will not change existing call routing. And so I put this graphic here. I hope you can see my mouse arrow because it will help understand what I'm trying to explain here. But this is a picture of like just your normal sort of residential neighborhood where we've got fishbones built, right? VEP software builds fishbones, constructs the comparison of the placed address point on the structure, potentially even the point of ingress egress, and kind of looks like there, right? And connects it with a piece of geometry to its geocoded location. What kind of happens in this upper right-hand corner of this image is that you kind of get these fishbones that start to slant a lot, especially if your range starts over here at 100 and ends up over here at 99, but the actual address, the highest actual address is let's say 165, for instance. These sort of herringbone, or these sort of pin bones, herringbone, whatever pattern, chevron pattern kind of starts to emerge. And if you have that case and a boundary just kind of comes straight through this block where my arrow is coming through, there's going to be 2 or 3 of these address points that aren't going to geocode against the road center line in the same PSAP as the placed address point, right? And so you'll want to find those locations, if any exist in your particular jurisdictional area, and you may need to adjust, you may need to break the road center line at that boundary, and you may need to adjust your address ranges on that road center line so that they geocode into the right PSAP boundary. And that's the recommendation here in 5.3 in terms of thinking about call routing based on a road center line versus call routing based on the placed point of a site structure address point. If that makes sense to everybody. Oops. It also makes recommendations saying that while it is not expected that data providers adopt the NG91 GIS data model for their internal use and maintenance of RCL or site structure layers, it is expected that data providers be capable of exporting their internal GIS data model into a format that complies with the 91 GIS data model. I think this is really some great advice here in section 5.3. It makes the point that you shouldn't, here's my recommendation, right? Here's the way I would say this as well, in full agreement with what the document says, that you probably should not be changing your internal maintenance schema to match 100% the schema of the 91 GIS data model. However, you may need to change the way things are parsed, some of the field widths or things like that. But instead of just changing it or adopting it, what you should think about is creating an ETL process, right? An extract, transform, and load process that would take data from your source database, your internal maintenance database, run it through a series of transformations, right? So that's where you could increase the field widths, decrease the field widths, right? Maybe you keep the abbreviations in your source database, but your ETL process actually creates the fully spelled out title cased versions of the word avenue and street and whatever else, so that you are fully standards compliant with GIS data model whenever you put your data into the spatial interface in the NGCS, right? This can be a complicated process to figure out. Once you figure it out, it's pretty easy to execute. So if you need any help thinking through how that might happen, that's exactly the type of work that we here at Datamart Technologies love doing, right? Section 5.4.1, again, getting into that section 5.4 where there's some specific issues that they make recommendations about in this document. Single, multiple, and stacked road center lines. You know, if you're a GIS data wonk like myself, the idea of a stacked road center line is kind of a scary one. It's kind of like that sounds like trouble. So they have some recommendations about that. I think I agree with all of these. First, flexibility exists in representing road center lines, right? You can either have a single line representation or a single carriageway, or you can have dual carriageways, right? Why would you have a dual carriageway? Why would you represent a road with dual carriageways? One reason could be that you're also using this data for routing services, right? Routing in a CAD system, routing in any other type of system that may be out there using the same data. The dual carriageway would be for instance, when you have a boulevard and one direction of travel lanes with one direction of travel are physically separated from lanes of travel with a different direction. The single carriageway is just as valid as the dual carriageway, but there are some advantages to the dual carriageways in other systems. The document recommends and states, right, exactly what I've have with a big red asterisk here to say, think about this. Don't accept this fully, completely without thinking about it, qualifying it. But it states that representation should prioritize LVF and ECRF usage over vehicle routing. I would say, in general, I think I agree with that. But there are some times when complicated situations arise where perhaps there should be the vehicle routing should supersede the needs of, and find a complementary way to do this, of course, because there's always a way that it meets the needs of the LVF and ECRF, but it also meets the needs, complicated needs of vehicle routing. So all of that to say is there's general statements in here that say it should prioritize that, but there are specific instances sometimes where you may need to kind of come up with some sort of in-between solution. Further in bullet point 3 here, the third one, a special care is needed when road center lines align with service boundaries to ensure correct geocoding. And that goes back to that graphic that we took a look at on the last slide. You may need to be splitting road center lines and adjusting address ranges. This should happen in the exceptions, not the rule, right? It shouldn't be happening all the time or often, should be very rare and an exception, but there may be some times when you need to break a road, adjust the address ranges so that geocoding occurs in the correct fashion. And stack geometry is used for unusual addressing, but it's not recommended for vehicle routing. So there are some cases where stack geometry sometimes is the only sort of messy solution that you might have. One good example of where this might occur is if you have the boundary between two jurisdictions, two PSAPs, two ECCs, that kind of splits down the middle of a road, and the right side is PSAP A, the left side is PSAP B, or even that it kind of is right on top of the road, not in the middle of the road, is at the back of curb on the east side, the west side, whatever. Some of those particulars would drive you to maybe need to represent both sides of that range in portions in PSAP A and portions in PSAP B. These are complicated situations, and this document couldn't possibly get into every permutation where that happens, but there are, suffice it to say, places where in the world where stacked geometry is kind of the best option for these unusual addressing cases. And then the final bullet point on this slide here, as a best practice, this is quoting from the document, stacked geometry is not recommended, particularly if the data is going to be used for other purposes, such as vehicle routing in a CAD system. You can imagine how a CAD system is trying to route down that same road. It may get confused, right? And so in that case, the stacked geometry may cause a problem. Again, general recommendations in this document are that you can consider stacked geometry, but also to understand that there may be downstream impacts to that stacked geometry, and you may or may not want to do it. Um, 5.4.2, spatial gaps and overlaps between road center lines. You want to ensure an RCL layer topology is free from unintended gaps and overlaps. Unintended is an important qualifier for gaps and overlaps. How are you going to have gaps and overlaps in an RCL, in a road center line? You may have geometric gaps and overlaps, right? Your snapping doesn't snap. Sometimes your brain doesn't brain, so your snap doesn't snap. But also you may have attribute gaps and overlaps, particularly as it relates to address ranges, right? And those are the things that you want to avoid, because if an address is in that gap or overlap, it would not be able to be found for location validation function purposes or emergency call routing function purposes, right? So snap road centerline endpoints together to avoid overlapping geometry or spatial gaps. You may hear these referred to as snap 2 points, especially around a big boundary like a PSAP boundary. You may go through and actually create a piece of geometry that's a point that says, hey, neighbor A and neighbor B, doesn't matter what happens in your data, let's make sure that we're always snapping to this one agreed to set down point. The third bullet point here, road center lines ending at a service boundary must snap to the same endpoint as in the adjacent jurisdiction. Again, defining what are those snap 2 points there for. And it highlights a best practice, right? Neighboring GIS data providers should work together to reconcile overlapping geometry and spatial gaps. Now, this is one of the biggest burdens of NextGen 901, GIS for NextGen 901, but also, frankly, in my opinion, one of the biggest advantages. You know, in the past, GIS data sets grew up in silos, separately from one another. Some of them concerned themselves with overlaps, some didn't. Some brought in their neighbor's data and a buffer because they needed to display it. Others, you know, kind of did things just in their independent ways, and now they have to come together and work together so that all the GIS data sets are consistent and tell the same story, so that the routings can be consistent and be the same. And so there is a great opportunity here, also a great effort that should go into neighbors working together on their GIS data. I'm seeing some chat in the chat box. I'm going to come back to that in a little bit because I don't have time to read all the words there, but Steph, let me know if there's any particular thing that comes out in the meanwhile. Section 5.4.3, recommendations on cul-de-sacs and coves. Circular features should use line work with right and left offsets for accurate geocoding within service boundaries. That's good advice. What does that mean to have an offset? You know, we have a validation that talks about self-intersecting lines. We'll point out self-intersecting lines. Those are things you want to avoid, and so you may want to have kind of an offset version of that road center line that represents it. Additionally, these things sometimes get represented as true curves, which are mathematical curves or Bezier curves, which are derived by math as well. I don't fully understand how those things get constructed. That's a little bit of GIS black magic, but those particular types of curves can cause data transformation issues because you may be managing this in a state plane coordinate system, but it needs to move into a WGS 1984 coordinate system, and it may actually change the location of those curves. And so you'll want to generalize your curves into a series of vertices on an actual line in order to avoid those transformation issues. For LVF and ECRF purposes, cul-de-sacs and coves can be represented with a single straight line segment, even if a physical island exists. So that's an important and good advice as well. Just run that line up through that physical island. Shouldn't be a problem. Section 5.4.4, road center lines split at boundaries. Splitting of road center lines will naturally occur where an NG911 data set data model attribute value changes. So when a PSAT boundary occurs, right, the responders, when any of those municipalities, incorporated communities, unincorporated communities change, there should be a break. But there's two additional use cases. One is for geocoding, right? We already kind of talked about it. When it's matched to a single road, location is interpolated along that road, that feature. If it's based on theoretical equal spacing versus actual address ranges, there are some considerations about that. And careful consideration is needed when splitting to ensure accurate geocoding because of the boundaries that before weren't really there because maybe there's a different EMS responder, even though it's the same incorporated community, for instance. The best practice recommendation here in this document, split road center lines where they cross NG911 required boundaries. Good advice. Continuing on in 4.4.4, I'm going to try to accelerate myself here a little bit to leave us some time for questions at the end. Road center line splits at the boundaries. Splitting of a road center line will occur naturally. That second use case, other RCL use case usage, right? You may need to make some splits where other systems are using the same data. To quote the document here in that second final bullet point on this slide, these systems may have additional attribution needs, use cases, which may have additional and or alternative splitting requirements. To reduce the amount of road center line splitting, some 911 authorities have adopted best practices recommending public safety agencies develop jurisdictional boundaries that coincide with existing or natural center line breaks, such as intersections and bridges. Well, there's a perfect world use case if I ever did hear one. I think we all live in reality where that's not necessarily possible, but in the occasions where it could be possible, it is good advice to perhaps adjust your boundary so that it does go to an intersection, but again, not always or probably even very often possible to do that. 4.5.4.5, representing multi-lane road intersections. I just did a screen grab out of the document here because it had some good graphics that show that. Sometimes you have two parallel road center lines, you have that dual carriageway. How do you handle those multi-lane road intersections, right? You can either do a pinched intersection or what they call a real ground truth intersection in a document. It can get complicated. If you take figure 5.2, you may have some road center lines where you have some 0, address ranges. That's okay, you can deal with that. I kind of like the pinched intersections myself because you don't need to do that, and it also doesn't mess up the vehicle routing uses of the same data set. And it states there in the last sentence, while either option is viable for the LVF and ECRF, the requirements of other software and systems such as CAD or vehicle routing will likely dictate which is preferable. Also, the preferences of the previous data owner that made choices that you have to kind of live with will have bearing as well. 5.4.6, road centerline splits at intersection and multi-level roadways. The standard practice is to split road centerlines at grade intersections. So if you're familiar with the concept of elevation, you know, if the surface street is elevation 0, the main lanes of an interstate that go underneath an underpass may be -1, and the ramps that go from the surface to the raised elevation may be level 2 or level 3, right? Depending on where you live, how complicated that system is. Those grade references, especially in the case of ramps, will need, in a vehicle routing system, will need to say this piece of geometry goes from level 0 to level 3, or is level 0 to level 2, so that it knows when it's going to pick that piece of geometry to recommend for a vehicle route. It knows that it's going to take me from the surface street here to the main lanes of the freeway going the direction I want to go. This practice does not affect LVF or ECF functionality because it just doesn't get considered in those cases. And to maintain vehicle routability, road center lines must have elevation attributes or be split only at intersections with the same grade. In other words, you wouldn't break that ramp, right, that piece of geometry that represents that ramp, into two pieces just because there was a boundary that came across it, because the where it starts and where it ends is a different elevation, may also be a different response boundary. So you'll have to work those sort of complicated scenarios out while you're at it. Recognizing the impact that splitting road center lines at intersections may have on internal uses of the RCL layer, these recommendations are made, right? If road centerline elevations are maintained internally, splitting them at intersections should not affect other business uses, and they may be split at the discretion of the 911 GIS data provider. For example, the proper attribution of elevation in figure 3, which I'll show, 5.3, which I'll show here in just a second, allows the road centerlines to be split at all intersections, right? Regardless of whether the two intersecting roads are at the same grade, if desired. So I'll move this 5.3 here. Here's the graphic 5.3 that's referencing. You can see the start and end elevations, 0 to 0, 1 to 2, etc. Hopefully it makes sense there. This shows the junction of ramps where the road center lines carry proper elevation attributes and therefore can be split at all intersections, regardless of whether these are true at grade intersections, without affecting other business uses. So the one I'll point out here, this 2 to 2, right? It's kind of the main lanes of a freeway, looks like. It can still be split here. I don't know why you would need to do that, but apparently there is a scenario where that's possible. Let me go back. The reference then in the final bullet point here for figure 5.4, the absence of elevation attribution, splitting of road center lines at intersections should only occur where the intersecting roads are at the same grade. And I'll move to graphic figure 5.4, 5-4. Shows the same junction of ramps that we were just looking at before, but the road center lines do not carry proper elevation attributes and therefore are only split on at grade intersections. So for me, my advice is usually that you would maintain this type of splitting even if you have elevations. But the point that the document is making is that if you have the elevation data, it can drive the vehicle routing without, despite the fact that you've broken up the geometry. So it's interesting to me that the group felt like this needed to be elucidated, but there are lots of options, and I think that's a valid point to make. Lots of things to think about in terms of how you might split those roads based on elevations as well. So landed the plane there at 10 till, just as I intended to, so that we would have plenty of time for audience Q&A. Looks like there is a question in the Q&A box from Deborah. She says, as far as flexibility with the RCLs, is there a case in a housing community where addresses along one side of the road center line are ascending and the addresses on the other side are descending and there are parity issues? Would you mark it as an exception or completely readdress all of the houses? Okay, this is a very realistic scenario, right? I mentioned earlier the kind of scenario where a road center line is the boundary between PSAP A and B. It's very much possibility, and I know of several actual use cases in the real world, where that's exactly what happened, right? City A addresses ascending from right to left, city B addresses ascending from left to right. And that they're on the same road and they've got all sorts of duplications of road points. They've got all sorts of parity issues. Those things happen in the real world and they are a mess. And so the question, would you mark that as an exception or completely readdress? Well, it depends on if you live in a perfect world or the real world. In a perfect world, yep, just go on, work with your city next door, and everybody readdress the entire road range and get them lined up. The likelihood of that happening is next to zero, right? A big political problem, a big technical problem to surmount, but it can be done. And I would probably do exactly that. I would make sure that it reflects real world in terms of the address points, reflect the addresses, that the road center line relationship between it and the address point is solid, and then mark exceptions to any kind of validation anomalies that pop up there, because as long as you're reflecting the real world in your GIS data, that's the most important thing that matters. So good question, Deborah. There's some real messes out there in the world. Looks like in the chat, a little bit of an explanation. Let's see, Dustin. Can you provide a better example or explanation for why you would have multiple or stacked road center lines? Yeah. So this is the one that I just gave is actually a good example of a time when I recommend maybe some stacking, right? Because the ascending addresses go opposite directions. The right side of the road center line goes to PSAP A, the other goes to PSAP B. Maybe you should have some stacked geometry in that case. And so, yeah, I'm a very visual learner. I totally get that. I wish I had a visual example of that to show you, but that's one good example. Looks like David gave some good feedback to that too. Appreciate that, David. Okay, yeah. Any other questions? Next in the series, not next in our webinar series, because there will be other topics, but the next time you hear from me about standards and action, we'll be talking about this document and its phased approach for creating civic location layers. Lots of really good advice for taking data that is in a current state and moving it into the end state needs of NextGen 911. And so be on the lookout for that coming down the way. Couple of announcements. The National Public Safety Telecommunicators Week is coming up. I think it's the second week of April. It's a great time to celebrate the work that public safety telecommunicators do, the very difficult work that they do under the headset. You know, I've never been under the headset, but I've been in the environments with them, and I know it's something that I just don't think I have the constitution to do. So I'm very happy that there are people out there that do that and support people in their moments of the worst needs. And so be on the lookout for that. If you are part of a PSAP or you support a PSAP with GIS, please take a look at this QR code, scan it, and nominate your PSAP. We're going to be giving away 24 hours of catering to the lucky PSAP. So take a look at that nomination process. And if you've got a great heart-wrenching story, it's likely to get a win for your PSAP. So submit that there. Also, just today, we've announced the creation of the location platform, a Datamark Technologies offering that combines the GIS data preparation capabilities of Datamark VEP along with the DDTI, now Datamark Technologies, spatial interface, ECRF, LVF, and LDB offerings. Though we've actually created direct integration between VEP and those next-gen core service elements that have long been available from DDTI. So if you're in a state or in a location in a region where those DDTI capabilities are available to you and you have VEP, all of a sudden we have direct integrations that you can directly send it to the spatial interface. If there are discrepancies that come up from the LVF, the ECRF, or the LDB, those will be notified to you in VEP and will help you make a much more efficient and effective data maintenance cycle for those discrepancies. It's something we're super excited about here in Nerdville of Datamark Technologies. And so if you want to learn more about that, be looking in your email, take a scan of this QR code, and reach out to your client success managers, your business development managers, your project managers, if you're interested in learning if that is a scenario that you can be involved in. So scan those codes if you want to learn more about those things. Let's see, what's our time here? We got three minutes left. Let's see, one question just came in. Is there any guidance or suggestion of center line in roundabouts, traffic circles? Yeah, so roundabouts and traffic circles are interesting. You really just have to break those down. You're essentially kind of representing them as dual carriageways of the same road. So that's kind of how you have to think about those things. It does matter if it's like two road intersection, or more than that, 3 or 4 or 5 roads. Those traffic circles can get kind of complicated. So I would definitely say get your particulars together and reach out to us if you have any specific questions about that. Hard to make blanket recommendations on those. Thank you for that question, Nick. I'll just back up. Here's my email address. If you have any particular questions like that, you want to send me some screenshots, you want to ask some questions, you want to set up a call where you can kind of show us what you got, feel free to do that. Reach out to me at that email address. Really appreciate everybody's time and attention today. Thanks for joining us, and be on the lookout for our next webinar announcement coming up soon. Everybody have a great day, and we'll talk to you next time.